In this video, I'm going to talk about the theory of linear functions first, and then I'll create a subsequent video where we'll look at an example or some examples of this. So a linear function is a formula that produces a straight line when graphed on a number plane. Okay, so if you recall with number planes, okay, so it's basically a set of axes, okay, horizontal and vertical axes. The horizontal axis is the x-axis. The vertical axis is normally the y-axis, and where the axes cross, right, we call that the origin, okay? And that's got coordinates 0, 0. Okay, so I'm assuming that you're familiar with coordinates and points on a number plane, okay? And you might have seen this in the past as well in year 9 and 10, where you might have done some basic graphing, okay? So this is a bit of a recap. We talk about the nature of the formula, or the form of the formula, I guess. It's gradient-intercept form. Okay, so the gradient-intercept equation of that line is y equals mx plus c. Now, why it's called gradient-intercept? It's because the formula involves the gradient, which is represented with the letter m, and the y-intercept, which is represented with the letter c, or the pronumeral c. So I've annotated this formula for you. The c is the y-intercept. X is what we also call the independent variable. So that's the variable that we can vary, that we have some control over. The gradient is represented by the letter m, okay? And the y is what we call the dependent variable. So this is the variable that changes depending on what happens with x. So it's kind of like you can sort of change the value of x, and let's see what happens with the y value. And being linear, it means that for any set change in x, the change in y will correspond to that, okay, or some scale factor of that. So what's the gradient? Okay, if you recall, the gradient describes the steepness of the line, okay, and we can also interpret that as the rate of change, okay, of y with respect to x. In other words, as x changes, what's the y value doing? Right, the y value could be doing something like this. So if x, for example, if we're talking about a gradient of 2, that means for every movement, or one unit of movement, from left to right, so this way, we're going up 2 units. Okay, then again 1 unit, up 2 units, and so on. Okay, we'll look at this through an example or later on. So just moving on. Okay, the y-intercept is the point where the line crosses the y-axis. Okay, now I've drawn basically a picture version of the equation y equals mx plus c. So this is the equation, this is the line. Okay, this is the line y equals mx plus c. Okay, so that's basically a picture version of this equation. Okay, now we don't know what m and c are. I'm just draw a random line there, as long as it's a line, straight line. There's the y-intercept. So this is what we mean by an intercept. Intercept means a crossover. Okay, so this crosses over, or touches or crosses over the y-axis. So that's the y-intercept there. The independent variable is x, so that's the horizontal axis. The y-axis here is the dependent variable, and the gradient, okay, is given by the formula rise over run. Okay, so the run is the distance along. Okay, and we always do this from left to right. The run is the distance along, the rise is the vertical change. So rise could be positive, so moving upwards. Rise could also be negative as well. So if the line's going downwards, the rise would be a negative value, in fact. So the last point is that gradient is always determined from left to right. And this can be quite an interesting point, that sometimes you forget this and you look at the gradient backwards. In fact, if you're looking at the gradient this way, in this direction, it's a downward gradient. That's incorrect. Okay, we read gradient, or we determine the gradient, or classify the gradient always from left to right, so in the direction that we read in English. Okay, so let's look at some examples of gradient. So positive gradient is basically an uphill. Okay, a level gradient is what we also call the zero gradient, is basically just the horizontal line. So it's equivalent to a level playing field. Okay, so if you were to put a spirit level or some sort of a leveling, even using a leveling app on your phone or something like that, it'll be 0. Okay, so there's neither sort of uphill or downhill. Negative gradients are exactly that. They're downhill and it'll be a negative rise. So instead of the rise being a plus, it'll be a minus on the top. By the way, run is always positive because we're always going from left to right. The rise, though, could be either. Finally, vertical, well, that's sometimes called an infinite gradient. That's where there's no run. The run's zero, in fact. The line goes basically, sort of straight up and down. Okay. Now, unlike my diagram here, use a ruler, please. Okay, keep your diagrams neat and tidy. I mean, I draw these freehand because it's a bit quicker, and also using the whiteboard ink rubs off very easily, so it's very difficult for me to use a ruler on here. But use a ruler, keep your work neat and tidy, especially the axes. I would recommend that maybe you draw the axes in pen, okay, because they're not going to change. The line itself, you can do that in pencil first, and you can pen over it later when you're done. Okay, so get the line where you want it to be, especially when you look at an example. That's just a little bit of advice moving into the examples. Okay, so in the next video, I'll do some examples on graphing some of these.